Thank you. Hello, everyone. I'm Vesa and today we will discuss about why old school engineering still wins and why building production-ready AI agents can be very, very boring. A little bit about me. My background has over 11 plus years in software engineering and ML system designs. My sweet spot stays in R&D and production-grade AI architectures because I always loved to transform the fancy word from the research paper into the real-world hands-on experience. And also because we are living in the social media and personal branding era, in my free time, I'm doing tech marketing and tech writing. Today, I'm wearing multiple hats. I'm the CEO and co-founder of Cube Digital, which is an AI outsource company based here in Timișoara. I'm also the co-founder of Hyperplane, which is a deep tech newsletter. And I'm also the CTO of CogniSync, which is a deep tech and Gen AI startup. Before going into technicalities, I want to take you in a short journey through time. And let's get back to the 2013, more exactly when I was only 18. A clueless but naive guy, very, very passionate boys. No fancy universities, no fancy funds, only a laptop. Back then, ChatGPT didn't exist, Transformers wasn't mainstream, and Hugging Face wasn't founded yet. The deep learning revolution was just warming up. Back then, the cool kids were talked about AlexNet, which is one of the first convolutional neural network for the image processing. And ImageNet and Kaggle was the battlefield for every engineer who wanted to learn something about computer vision. And me, I was trying to catch up very, very fast. So I took a bank loan, I skipped the university, and I took the PyME Search University, one of the most important online class from that time. TensorFlow didn't even exist yet. We were still using Theano and Caffe. And at that time, AI wasn't magic yet. It was all about math, statistics, probabilities, and engineering. So to conclude this, back in 2013, everything was about research papers, deep downs, trial and error, debugging neural networks on CPUs, understand datasets, and some niche communities. And of course, today, we all live in the ChatGPT mirage, which say, I'm going to ChatGPT, describe my dream, and I hope that ChatGPT will fulfill it. But it's completely wrong. So basically, I knew that I needed hands-on experiences. So I got to work at Continental, Flex, Coca-Cola, Pioneer, Qualcomm. From ML engineer, computer vision, embedded systems, to startups, I said yes to everything. I changed the corporate environment when I learned about people skills, people management, processes, discipline, everything, to the startup environment, where of course, everything was war. So yeah, backing days to 2025, I realized that over the years, 80% is all about infrastructures, and 20% it's magic or intelligence. So the agenda from today will be we will discuss a little bit about AI foundations, engineering before agents. We will discuss about what is agentic AI and what is not, more important. We will discuss about failure modes in production. And of course, we will tackle one real-world case study of building an AI agent on edge device, which we called Build Your Own Siri. So, does anyone remember these plots? These plots, this is what building AI looks like in the past. This isn't a prompt. It's a TensorBoard dashboard, which have six loss functions, which teach us how the model is learning, how the model will fail, and why the model is breaking up because the learning rate is broken. And of course, if we are going to talk about signal, because in the past everything was about the theory of the signals, we can see, for example, that even though the regularization loss is going down, the total loss is going up. So basically, in the past, we had to catch it ourselves. Now we are hoping that ChatGPT will catch it, but again, it's a false impression. So, one of the core foundation of AI is understanding your data. And I chose those pandas because I love pandas, but also because these pandas give me a lot of memories from the past. Because in the past, as a data science engineer or ML engineer or deep learning engineer, we were used to understand each layer of data. So before the era of plug-and-play system, where we take a CSV files, go into GPT, analyze the CSV, and talk to it and give them all the statistics, we had to understand every layer of the data. So, AI wasn't always about speed or scale, because today we are living in the era where we are believing that speed is everything. But in the past, it wasn't all about black box prompts or auto magic agents. We had to understand each data layer. We had to understand how the model is trained. We had to evaluate and understand why the model has some false positive or true positive or true negative. We always were used to ask ourselves and our team, why this model work, not how fast can it generate. It was more closer to what software engineering taught us. Systems were designed to be monitored and optimized, not just prompted. So, I think that all of us who did some AI in the past were used to use these Jupyter notebooks and Conda environment. And what can I say from my personal experience? In the R&D ecosystems, we didn't know about software engineering. We always wanted that DevOps guys take those models, take those scripts, and go into productions with them. So this evolution goes into structured pipelines, more later to production MLOps, and today to the plug-and-play systems, as we call today, agents. But how can we truly ensure that this evolution doesn't end up controlling us? So, I won't give a definition about AI agents, because you can go and search on Google, and you will find a lot of them. But we can go back in history and look, for example, in 1976. But one of the most, my definition for the agent is like this. An agent is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. So basically, in 1995, we had the first definition, and we had the first sign that AI agents will become one of the most important software part of our world. So as I said, AI agents are not new, but the rise of LLM models make it possible. But before that, I want to emphasize the idea that building AI systems is very boring. And let's understand in the first place some data. So let's say that in 2022, AI was very, very expensive, complex, and often not worth the investment. But OpenAI decided to change the world, and they launched ChatGPT. But if we go deeper, we can see that from clear statistics that in the past we needed at least 11 people required to build and scale the AI solution. Also, it was very expensive to operate a single solution. Return of investment, in each project the return of investment was a problem. And in my opinion, today, it's one of the most important problems in the AI project. And as you can see, 85% of AI projects fail to generate return of investment. And also, we have this engineering reality, which goes to the infrastructure, to the logging part, and also to the observability part. So let's get back to the early 2023, when the ChatGPT has launched its application. The API-driven LLMs with prompts started to conquer the world. And of course, it was very sexy at the time, because we've seen a lot of startups which had several applications with a lot of prompts in the backend, and we had fast response, but no structured output at the time. And it's a fun story because we had the first fail. Basically, we had these cases, for example, DBT error caused chatbot to serve at its customer. So basically, we didn't have any control to our chatbots at that time. And also, one of the most interesting stories, it's a startup which is called Do Not Pay. And basically, here we have the perfect use case when marketing wins against the tech industry, because the CEO offered $1 million to each lawyer who has the courage to go in the court and use their chatbot. But after some statistics and some tests, FTC fined them for false claims. And it's a very, very interesting case study to go deeper. But later, in the mid-late 2023, we have the rise of RAG. And we all know that all the internet, all the industries, all the startups started to build RAG systems. But in my opinion, at that time at least, nobody understood what really means to build a RAG system. And okay, we had a lot of advantages. We can have an LLM who can watch over our internal data, learn from our data. We have more structured output, more faithfulness, and more accuracy. But one of the most important problems at the time with the RAG systems, which was we didn't have guardrails. We didn't know how to measure the output at that time, and we didn't measure the cost on each LLM call. From mid-late 2024, agents came into our world, and it were everywhere. I think last year in summer, the internet was boomed. And any AI influencer, any big companies, the CEO of NVIDIA, CEO of Facebook, everybody talks about AI agents. But at that time, and I think right now, we don't know what agents really are and how the agents can help us to scale our products or to give us some return of investment. And the real problem with the AI agents, in my opinion, was we didn't understand how an AI agent can use those tools. And as you know, those tools can be your internal database, some websites, some RAG systems, some NoSQL database, everything. But the biggest problem here was how do we really evaluate the output of the AI agents? And here we don't discuss about costs of deployment and the ROI of the AI agent. So let's see some failure modes from the production. So in the first place, I think that we as an AI engineers, we should always educate the business environment about what decision they should take. And I think that one of our main job is to tell them that it shouldn't have been an agent after all, even if they say to us, I want one of those. So always start with the question, do we really need an AI agent? And the framework we are using also in the outsource part or when we are building our own product, it's like this. We have a clear separation between what means an AI automation, AI workflow, and AI agent. Because today, as you've seen, everybody wants to use an AI agent for everything. Send them email through the AI agent. Let's talk with an AI agent. Let that AI agent talk for us, take the decision for us. But it's very, very wrong, because sometimes simple is better. So, to go more deeper to the question if we really need an AI agent, we should start with the question, is the process highly predictable, repetitive, and governed by fixed rules? And here we are going back to the classical machine learning, to trying to have a deterministic output with a stochastic algorithm, like, I don't know, ADA boost or logistic regression. So most of the case, at least from my experience, can be solved with automation or AI workflow. And the AI workflow can be governed by a simple LLM with predefined steps, like the classical if-else, if-else, as we all know. So, one of the worst statistics out there is that only 38 of the projects fail due to unrealistic expectations. But we all hearing that, but ChatGPT can do that, can execute that. But it's really true? So, the unrealistic expectations of the business environment, at least. We always, the business environment are expecting that AI agents can solve everything, but again, they didn't define what they want to solve with that AI agent. So basically, they are expecting full automation, and they're expecting big improvement. And they want to skip each steps from the classical machine learning process, which was, let's understand the problem. Let's do some research and development. Let's build a POC or an MVP, and let's iterate and test with the client. Another big problem here is that there are no metrics. Basically, from all our projects we were built, at least from 2 years right now, the client didn't define any success metrics for that AI agent systems. We didn't have any baseline. So basically, it's so hard for us as technical people to say, OK, this AI agent system is working. Another failure mode, and I discussed this in the beginning, in my opinion, it's always about data. It's not my AI, it's the data. And the solution here is that, okay, we can build a rack system and everything is solved, but I think it's wrong. Because what I observe in practice is that we don't know how to analyze the data because we are skipping the foundation principles of analyzing data. Because today we are working with multimodal data. We have tables, we have images, we have text, we have videos, we have a lot of data. And if we go into the enterprise field, for example, we are working with a lot of dirty, old, and mixed data. And our job as data engineers, machine learning engineers, AI engineers, is to educate the stakeholder that we need time to analyze and understand the data. Because if we invest enough time in find out what the data wants to tell us, in my opinion, the project will succeed. And also why it's important to understand your data, because based on your data, you define your metrics, you define your evals, and basically you define the success metrics for your project. And of course, I think that all of you knows about that hybrid search trend, and I think that Quadrant, one of the vector DB, was the first vector DB who came with that search, with that trend. When we have multi-vector configuration, we can have images, we can have text, we can have dense vector, sparse vector, Colbert, Matryoshka. But in practice, it's not enough if we don't understand what data the client has. And what I want to tell you here is that it's important to go back to the main principles. Build a Streamlit application with data labeling. Let the client upload all the PDFs, all the data, and try to do the classical data labeling. Because it's important to have metadata on those data points, because this helps us to build filtering systems and also helps us to build eval systems in the end. So 70% of AI projects end up on the island. And as you know, all the clients said, OK, this was a POC, this was an MVP. Let's not tell to the IT department or to the investors. And another problem I've observed over the time is that we have the poor integration. Basically, we have a real problem in the first place with the people. Because as you know, Gen AI, generative AI, is a new field. So people didn't have time to prepare for that. And the companies and clients and the industry don't want to understand that. And because today we are used that a back-end engineer to know also AI, to know also data science, to also know front-end, we are lacking of expertise. Another problem is the process, because the companies, and whenever we are building an AI systems, we don't understand the classical process, the manual process. And what I'm trying to tell to my AI juniors from my company and to all the people who I'm talking to is that before doing any AI stuff, before doing any ML stuff or deep learning stuff, try to understand that manual process. Try to understand how that process is working right now in the company and how it's measured. And also, I also discussed about data and technology, because right now we want to integrate AI agents in the legacy systems. And we cannot do that. Or we can, but we need to understand that legacy systems. We need to refactorize that systems and all other software principles. So we go to the MLOps principles, which are all about iterate, automatize, standardize, and version, and also about track experiments, but I will discuss later about this. So, another big problems, and we also have seen that at our outsourced company and also our product at CogniSync, it's great tech, but it's bad business. And we always have that in mind. ChatGPT is only $20. Claude, it's only just $20. But the real problem is that the big tech companies tricked us because, okay, the cost of LLM token cost has dropped by a factor of 1,000 in 3 years. And they tricked us that, oh, it's nice, we can build everything based on LLM APIs, on foundational LLM APIs, because we are not looking to the small language models. We are going directly to the ChatGPT, to the Claude, to the Gemini. So the truth is that LLM application operating costs risen by 22% in just 1 year. And why is that? Because when we are building an AI system, we don't have any plan. Basically, we don't have any plan. We take that API, import OpenAI, go in Python, write a prompt, and everything gets solved. But what's happening when you take that prompt and multiply it by 100, for example, and you have 100 calls to a single API? Let's don't discuss about data ingestion, data indexing, retrieval part. So the problems is at us, the people who are building the AI. Because we are not educating the client and we don't educate ourselves to understand what's behind that LLM call. So most of the time, we are used to build complex tasks or complex system architecture without taking into consideration that simple LLM calls. And one of the most interesting story of these times is this LexisNexis Westlaw, which built a chatbot, a legal chatbot, and they said that they have free hallucination. And it's very, very wrong from a mathematical point of view, statistical point of view, because as you know, the LLM output, it's stochastic, and you cannot have 100% hallucination free. But it was very funny because some guys from Stanford test the product and benchmarking on queries, and they find out that one of 6 outputs of this product, it's wrong. And again, what I want to emphasize here is that agent evaluation is very, very different than model evaluation. Because, okay, let's say we are building an LLM application, we have 100 prompts. It's important to evaluate those 100 outputs on those prompts. But what about agentic evaluation? Because agentic evaluation right now is very, very complex. And I've seen a lot of AI products in production which are not using any evaluation systems for this part. And let's say, for example, we have the tool from Arise, or we can even have the LangGraph evaluation tool. And as an AI engineers, we should understand why the AI agent choose, let's say we have 10 tools. Why that AI agent chose that tools in that query. And it's very, very important. And also, it's important that, because at agents we have that plan reasoning and the feedback loop part, it's important to understand how many steps does the agent do to solve my problems and how that part can go exponentially or linearly in my product, and it's very, very important to do that. So the reality in 2025 is the same as 2022. We have the hype. Everyone wants an agent, but again, the cost explodes a lot. We can see in the last report from Snowflake, we have only 47 report profitable AI investment, and we have a 14% reporting negative ROI. And what I've also seen, and I was part of many projects of that, 42% of companies scrapped most of their AI projects. And what I can I tell from my experience is because they didn't have a clear output of why they wanted to use that AI. And of course, between 70 and 85% of GenAI deployments fail to meet goals because when you go at the end of the month to the, I don't know, SageMaker cloud infrastructure and you see that you have tens of thousands of euros to pay, you say, okay, this project has no return of investment. So, when you want to build an AI agent system, you have to take in consideration one of the most important, in my opinion, is the use case you are trying to solve. You have to be aligned with the stakeholders' expectations. You have to understand your data. You want to predict how many iterations you can have on that project, and also the runway cost. And it's very important to try to predict the runaway cost from the beginning. And from our calculation, if we are doing this, we can achieve 3.7 more return of investment. Okay, so let's go to a more real-world case study. And we at Hyperplane started to build our own Siri. So basically, it's an AI agent systems on the mobile, Android, and iOS, and also desktop for one of our clients. But before building a Siri AI agent, we had to answer to 4 questions. Who are we helping? What's the daily pain we are removing? What's the simplest possible tech that can do the job? And can we really measure the business outcome? And okay, the requirements from the clients were pretty simple. We have the privacy and control. We want the latency to be almost 0, real-time stuff. Of course, they want differentiation because, as you've seen, we all have Meta in our WhatsApp environment. And basically, they are the competition of WhatsApp and Signal. And of course, the cost management, because they didn't want to pay money to the big tech companies. So, unfortunately, the architecture is not very clear. But after we received the requirements from the client, we started to build a diagram, an MVP diagram for them. So basically, we started from one of the most important aspects when you build a custom AI agent, which is the data generation flow, with all the MLOps principles there, and I will go deeper in the next slide. We have the fine-tuning part here, because when you try to take a small language models and put on the mobile, you have to do fine-tune, because small models are dumb. And of course, we have the testing part on different environments. And here we've chosen to test on our Mac systems, Raspberry Pis, and also on the Android and iOS. So, how do we really define the scope of the AI agent? One of the most important and one of the most skipped part in any AI project is the STT and SLM benchmarking. And why here is the STT and SLM? Because the client wants several tasks like grammar and punctuation fix directly on the mobile, rephrasing, filter word remover, and smart reply generation. So basically, we have voice models and small language models. But if you go on the internet, you will see that you have several models like this. So how do we really choose between these models? And another big problem is that the client wanted to have 6 languages. So the problem started to be very, very complicated. So we stayed and do some research and said, OK, we need some open source data set on each language. And also, we need to generate some synthetic data, because we need to do some benchmarking to choose between these models, because we have memory constraints, we have cost constraints, speed constraints, everything. So we've started with the benchmarking process. We've taken 3 models from the open source. We have Whisper, CPP, Celero, and Vosk with the open source data set. And for the text-based part, we have Gemma 3 billion, Quen 1.5 billion, and we have that Llama 3 billion. Of course, these are quantized models because we are running on the low-edge device. So we've started the benchmarking. We already had a label data set from Hugging Face, but we also created our own synthetic data with the human label and also the large language model label. So we did a benchmark with those languages and had the first impression on what model can we use. So the client came to us and said that, how do we really choose between prompt engineering and fine-tuning? And this can be a very, very complicated problem, also when you go on the edge part, or when you run your own LLM. Because we are used to do a lot of prompts to the big LLMs, and most of the time, the prompts are working. But from my experience is that, let's say, 1 billion, 2 billion, 3 billion models are very dumb, and when you change a single word in the prompt, the output of the LLM is changing. So the benchmarking was split in 2 parts. We've tried the benchmarking with the prompt engineering, and we also tried to fine-tune the model. But when we come to the fine-tune model, we encounter a big problem. And one of the biggest problems is that we needed to fine-tune the model for a function calling tooling. I mean, the small language models should be able to call at least 10 functions from the mobile. So when you go to the internet and search for the data set, you will find that, OK, there is no data set on that. So how do we really build a data set which can achieve our goal? So we go to the internet and we find out that Salesforce, open source, their best practices on the function calling data set, and build an entire workflow, an entire pipeline of generating synthetic data with our tools, 10 functions, based on that. And here we try to respect all the MLOps principles, from how do we really track the costs, how do we really measure the health of the data. And here was very interesting because this process cost approximately 3,000 euros. It was very, very expensive to generate data points for each case, because we also have a lot of data augmentation part. We had that augmentation paraphrasing, and also we used the classic and hard negatives examples, which we are calling right now adversarial examples. So after we had the data set, we start to fine-tune the model. And here it's an entire I mean, in my experience, there is no technique. There is no best practice on how can you really fine-tune the small language models. There are no articles, no documentation on that. So we had to experiment on that. So we've started with a llama model, and in parallel with Gemma, and also we used the Onslaught framework. And also because, as I said, the MLOps principle is very, very important, we used the experiment tracker, and here was weight and biases, but of course we can use also LangFuse or CometML or OPIC. And here was very, very interesting because at the export, we don't have yet the quantized model. So basically, respecting the best principles and the foundation of AI, we have two models. We have the large one, and we have the quantized one. So we had to do the benchmarking on both of them and see how can we really improve that quantized model. And of course, we need the model registry because you want to version and checkpoint your fine-tune part. And in the end, after we had our first model, we starting to test on our ecosystem. So basically, we had our Mac systems and the Raspberry Pis because we wanted to run on the low-edge device. But the results were pretty well here because we already had a labeled data set. But in practice, on the mobile, the things stayed very, very different. And what I wanted to say here and to conclude is that it's very important when you run your own AI agent systems on the edge or even on the cloud, it's important to take a subset of your users and do a lot of A and B testing and measure with them the output because this is lab stuff. We train on our laptops, we measure on that. But we said to the client that you need at least 20 users from iOS and Android, let them test, let us collect the data, collect the feedback, and retrain the model, regenerate the data set, measure again everything. So to be sure that we have a return of investment on our project, as I said, we have to start with the right use case. We have to analyze our data. We have to have a modular architecture and also take in consideration the model behavior, it's state machine plus reasoning plus fallback, and all of them can be errors in our systems. Also, it's important to have observability, cost management, and don't do the mistake we did in the past. A working prototype is very, very different from a production system. And I wanted to tell you something. In this morning, we find out that, very interesting on Reddit, a critical security vulnerability was discovered. And it's amazing that AI agent doesn't do the difference between an actual virus and other stuff. And I wanted to raise a warning here. I want to conclude that hard work can be talent if you commit to it. And thank you.